Hello everyone, in this video we are going to see about the two-way linked list. It is also called doubly linked list. As the name implies, the two-way linked list, we can make the transaction in both the ways. A two-way list is a linear collection of data elements called nodes, where each node n is divided into three parts. So what are the three parts? One is the information field, and next is the forward link which points to the next node, and the backward link which points to the previous node. So these are the three parts of the nodes in the two-way list. The starting address or the address of the first node is stored in the pointer start or first. Likewise, the last or the end is the pointer which has the pointer which is at the end of the list. So this is the diagram to show how the two-way linked list works. So now here we can see the direction is bidirectional. The directions are in both the way, so you can follow the link either in the forward or the backward direction. So we can see here that this is the information field, and this is the backward link, and this is the forward link. We can also say it is a node, data, the next and the previous. So this is the header node which implies the starting of the list, and this null indicates the end of the list. Since it is two-way, we can also, the end can be in both the directions, in both the points. Okay, let us see how the doubly linked list, the operations are done and how the pointers are fixed. Doubly linked list is a variation of linked list in which navigation is possible in both the ways, either forward and backward, easily as compared to the singly linked list. So here when you say what is navigation is possible, means we can move either backward or forward. Following are the important terms to understand the concept of doubly linked list. So we have link, and then next and the previous. As we just seen before, the node, backward and the forward. Here we have the link, next and the previous. So we can mention in both the ways. So what is the link? Link is the node which contains the data. Next is the successive next link. It is called as next pointer, and previous is the previous data. So now let us see how the linked list contains the connection link to the first link called the first, and to the last link called the last. Let us see the diagram of how the linked list looks like. As we just seen before, is another way of representation. We have this the block of three fields. This is the data field, and this is the previous, and this is the next one. Likewise, it goes successively. We have both the directions, next, forward as well as the backward, and we have seen as before the same thing here. Null is the null pointer which says the end of the list, and here this is also a null pointer which says the end of the forward list. So this gives the forward list end, and this gives the backward list end, and this head gives the starting of the list. So the same is represented in different way. So null is one pointer in both the directions. So here this representation has no header position. Okay, so here the node, previous and the next. Likewise, node, previous and the next is connected to the next node, and the previous is connected to the previous node, and this way the links are connected like the chain. Okay, let us see with an example how this doubly linked list helps to represent the data. So this is the data of a hospital having the bed number and the patient name. So the first and here forward and the back link are there. This is a doubly linked list concept. So here we are having three more pointers, the first, the last and the avail. So we know that first is the starting of the list, and last is the end of the list, and that is avail is the available free space in the list. Okay, now how to follow this list? First, the first link starts with the 5. So you have to go to the location to 5. The first patient is Adam. Okay, so now if we want to see the patient which is after Adam, we have to follow the forward link, and if we want to know the patient name who is before Adam is the backward link. Since it is the first name in the list, Adam has the successor but not the predecessor. That means Adam has the forward link. There are in the location 3 the patient Dean is there, but before Adam there is no patient because Adam is the first patient. So back is 0. This 0 implies the null pointer, which is the presented in the as a null in the previous slide. And then suppose if you take some other example, 9 is the last node means, so 9 is Samuel, so next to Samuel nobody is there, so the forward of Samuel is 0 but the backward of Samuel is 12. That means before Samuel the patient name is in 12 location, so 12 bed the patient Nelson is here. Okay, so since Samuel is 9 is the last patient, there is no forward link which is 0, which is the null pointer. So this null pointer implies the end of the list. Okay, so likewise suppose if we want to, so the advantage of these particular two-way list is we can either go backward or forward. Suppose I have end up with the searching of the patient Nelson, I wanted to know who is before Nelson and who is after Nelson. So before Nelson is the back pointer and after Nelson is the forward pointer. So after Nelson 9 is the patient which is Samuel, and before Nelson is 4 is the patient Maxwell. Okay, so likewise at any location I can find out the successor and the predecessor values. So this is the example and the use how the linked list helps to traverse or navigate in both the directions. Let us see the operations on the linked list. In general, any list can be traversed. What is traversed is just visiting the node exactly once. So in order to process a data, we have to traverse the particular node. That is the visiting or the traversing of the particular linked list. So each node is visited exactly once. So we have done the algorithm for one-way list. There is a singly linked list. The same can be used for the two-way list also. So we can refer to the video which traverse the one-way list. Likewise, we can for the searching also we have done an algorithm which is given in the previous videos, the searching of one-way list. So what is the main process in searching is, given a key value we have to find the list from the starting to end till the value is reached or the value is not at all available in the list. So the same algorithm we have done for the singly linked list can be used for the doubly linked list also. The main advantage of this doubly linked list in searching is the item can be either searched backward or in the forward direction depending upon the location of the data. For example, suppose list is a list of names stored the names in the alphabetical order. The names are sorted in the alphabetical order means, suppose if you want to find out the item called Smith, suppose Smith is the key value, you can naturally search the list in the backward direction because Smith is almost in the end of the list. Likewise, suppose if you are supposed to search for the item Davis, we would search in the forward direction because the David is in the starting of the list, because D comes in the starting location of the alphabetical order and S comes in the last order. Okay, last location. Now next the operations are the deleting. So how to delete any node in the doubly linked list is, we have to first connect the pointer of the, first you have to remove the node. How to remove the node means, once you remove we have to disconnect the pointer. So that is the means how the data or node is removed from the doubly linked list. So how to do this is done by changing the pair of the pointers. Why the pair of pointers? Because we have both forward and the backward pointers. So both the pointers has to be set when you remove any node n from the doubly linked list. So we have back of LOC and a forward of LOC means, LOC is the node location where we are going to, which node we are going to remove, that is the location LOC, and this LOC has both backward and the forward locations data. So both links has to be disconnected. In order to disconnect those pointers, this line of statement is used. Forward of backward of LOC is equal to forward of LOC, because we are removing the back pointer. Likewise, back of forward of LOC is equal to back LOC. That means we are removing the forward pointer. So we are removing both the backward and the forward pointer in order to remove any data from the doubly linked list. And then the deleted node n is returned to the avail list. Avail is the list of freely available space in memory. So once any data is deleted, that location or the memory has to be returned to the avail location. So this is done by forward of LOC is equal to avail and avail is equal to LOC. That means we are removing the data to the avail location. And let us see how the deleting can be done using this algorithm. The same is given in the step-by-step approach. So delete W, that is the we are just deleting the word in the doubly linked list. So information forward, backward, avail, LOC. Information is the data field, forward is the next pointer, and back is the previous pointer, and avail is the list of the available memory space, and LOC is the location for which you are going to delete the particular node. So step 1, delete the node. So what is deleting? Set the forward of backward of LOC is equal to forward of LOC, and backward of forward of LOC is equal to back of LOC. That means we are removing the back pointer as well as the front pointer for the data in the location LOC. And then once it is removed, that memory has to be returned to the avail list. So that is done by set forward of LOC is equal to avail and avail is equal to LOC. That means the data which was occupied by this LOC data is pushed to the avail memory, and now the forward of LOC will become the avail data. Okay. Next one, that's all, exit. So these are all the two simple steps how to return or remove the node from a doubly linked list. It is shown in a diagram like this. So here we can see this is the starting from, these are all the nodes of the particular doubly linked list, and then we have both the front and the back pointer. We are going to remove this node. We can see here this link, this data comes, this dotted lines says that this is virtual. That means we are going to remove it. So node n has to be removed. Once node n has to be removed means the forward link and the backward link has to be removed. So how to remove this? Forward and the backward link has to be connected to the previously existing node. So this whatever you're going to remove, that node is given to the LOC location, and then the backward pointer is forwarded to the front of the previous node, and likewise the forward pointer of this is removed to the backward of the next node. So that's what done by the assignment statement. So once you remove this pointer, this backward and the forward pointers point to the successive and the previous data, backward and the forward link. So this is how the deletion is done in the two-way list. And then how to insert the data. Once you want to insert the data, we have to find out the location in which we are going to insert the data. Now assume we have the data of location A and location B. We are going to insert a data in the list between A and B. That means we are going to insert a data between the location LOC A and LOC B. So how to insert? Item is the data to insert. So first we have to remove the first node n from the avail list. So avail list consists of a list of freely available memory space. From that available memory space, one node is removed, and that is given the new data, and that data has to be assigned to the avail first node, and then we have to change the pointers. So first, how to set the avail list? New is equal to avail, because there is a new is the newly entered data, and avail becomes the new data, and avail is equal to forward of avail, and information of new is equal to item. So to the new data we are going to push the value which is got from the item, and the forward pointer of avail is pushed to the forward of avail. That means we are just progressing the pointer to the next location. So this is how the avail is removed from the avail list and it is attached with the new data. Now the node n, which contains the item, is inserted into the list by changing the following 4 pointers. What are the 4 pointers? We have both the forward and the backward pointers, and there are two for the previous and the successive data. So this is for first line for the forward pointer and second line for the backward pointer. So we have both location A and location B. So forward of location of A is equal to new, likewise forward of new is equal to location of B. Now in between A and B, new is inserted. Likewise the back pointer. The back pointer of location B is equal to new and back pointer of new is equal to location A. So between A and B, the forward link is inserted, and between B and A, the backward link is inserted. So that's all how the insertion done. This is shown as the pictorially by this diagram. This is the new node we are going to attach. Once the new node it is got from the avail list, and once the new node is got, the forward and the backward pointer of the previous node and the successive node, node A and node B has to be changed. So the pointers are changed this way, and the newly inserted node is in the list now. So this is represented by the algorithm this way. The insertion within the list, information, forward, backward, start, avail, LOCA, LOCB and item. These are all the parameters of this algorithm. And now first we have to check for overflow. Why we have to check for overflow is, if you want to insert any data, we have to check if whether insertion of data will create an overflow in the list. If there is an overflow, if avail is equal to null, then write overflow and exit. That means if the available memory space is not there, that means if it is null means we cannot insert a data. So it is an overflow and we have to write overflow and exit. Next we have to, otherwise we have to remove a node from the avail list and copy the data into the new existing node. For this statement, new is equal to avail and avail is equal to forward of avail and info of new is equal to item. The same we have seen in the previous slide. Now it is given in the algorithm format. Then insert node into the list. Now we have to set both the forward and the backward pointer by these two statements, and that's all. We have to exit the algorithm. So these are all the ways by which the traversal, searching, insertion and deletion are done in the two-way list or doubly linked list. Hope it is easy to follow, and thanks for watching.